I hope you are enjoying the experience. Till this point, we have learned about fixing formats, removing duplicates, and handling missing values. Now, our dataset is ready, and it's time to analyze it. In this module, you will learn to analyze data using statistics, pivot tables, and descriptive statistics. And in this video, you will learn the foundation of all data analysis, particularly about descriptive statistics. What are descriptive statistics? You may ask. And how do they help us in general? In simple terms, these are simple calculations that make numbers tell stories. We will learn the essential statistics that help us turn numbers into actionable insights. So let's begin. The first statistic is count, the simplest but most important. Count tells you how many values you are working with. In Aisha's cleaned dataset, there are 53 tenders with awarded values. Why does this matter? Because it tells us our sample size. If you had only 5 tenders, your conclusion would be weak. 53 tenders give us a reasonable foundation for analysis. The formula is straightforward. Count equals the number of non-empty values. Always start by counting what you have. This also reveals missing data. Aisha started with 59 rows, but only 53 have amounts. That means 6 tenders are missing this critical information. The second statistic is mean, the average. Mean is the sum of all values divided by the count. For the awarded amounts, the mean is 67,34,778 rupees. This is the typical project value. Mean helps us understand the central tendency. What's a normal project cost? District collectors can use this to budget future projects. If someone proposes a new embankment and it costs 67 lakhs, that's right on average. If it costs 2 crore, that's much higher than typical. It needs justification. The mean gives you a reference point for evaluating individual projects. The third statistic is median, the middle value when all numbers are sorted from lowest to highest. For instance, in a class of 20 students who have just received their exam marks, 2 students scored above 90, but the remaining 18 students scored below 50. If you calculate the mean, those 2 high scores will pull the average up, maybe to 60 marks, but the median would be around 45 to 50, showing what most students actually scored. The median reveals the true story. Most students struggled, even though the average looks decent. In Aisha's data, the median is 23,74,003 rupees. Now, notice something important. The mean is 67 lakh, but the median is only 24 lakhs. What's causing this gap? Why? Because unlike mean, median is not affected by extreme values. A few very expensive projects are pulling the mean up, but the median is showing what typical projects actually cost. It shows that half of all projects cost less than 24 lakh and half cost more. This may be more representative of typical cost. The fourth statistic is range, the spread between the smallest and largest values. The smallest tender is 4,700 rupees and the largest is 6 crore 30 lakh. The range is the difference. 6 crore 30 lakhs minus 4,700, that's over 6 crores. Why does range matter? It shows how the variability in your data is. A huge range means projects vary widely in cost, from tiny repairs to massive infrastructure. This tells district collectors they can't use a one-size-fits-all approach. Small drainage work and large embankments need different planning, different timelines, and different oversight. Now, here's the story these numbers tell together. Remember, the mean is 67 lakh, but the median is only 24 lakh. What does this difference reveal? It tells us the data is skewed. Most projects are relatively small, clustered around 20 to 30 lakh. But a few very expensive projects like that 6 crore embankment pull the average way up. This is critical for decision making. If you only looked at the mean and said, typically project costs 67 lakh, you would overestimate. Most projects actually cost much less. The median gives you a more realistic picture of what most projects look like. When the mean and median are very different, always investigate why. In this case, it's because of a few high-cost outliers that legitimately need more money. Now, it's your turn to practice. I'm going to show you how 5 tender values on screen are. Your task, calculate the mean and the median. Pause this video now, write down these 5 values, calculate both statistics, and then come back and we will check your work together. Remember, mean is the sum divided by count, and median is the middle value when sorted. Go ahead, pause now and calculate. Welcome back. Let's check your work. The sum of these 5 values is 2 crore rupees. Divide by 5 and you get 40 lakh. That's the mean. For the median, the values are already sorted. So the middle value is the third one, 28 lakh. Notice again, the mean is 40 lakh. The median is 28 lakh. The 90 lakh outlier pulled the mean up. You have just learned how to make numbers tell stories.